Now you can see, right?
Yes, sir.
Yes.
So in the last class we started about analysis. So we'll start again. So whenever you are writing an algorithm, or maybe you are going through an algorithm that is written by someone else, we need to analyze it on the basis of its performance. Okay, how good it is. So we can analyze them on the basis of three parameters. थोड़ा theory में बता रहा हूँ. Okay, one is efficiency, another is finiteness, another is correctness. Efficiency, finiteness, and correctness. Finiteness means it should not run for an indefinite period of time. Okay, no matter how efficient your algorithm, for any input, it should not run for indefinite period of time. For any input, algorithm should not run for indefinite period of time. Okay, that is about your finiteness. मतलब the algorithm must end no matter how big the uh, input size is. Then correctness means doesn't matter what input you give to the algorithm, it should always find the correct answer. It should not be like if you are giving a small input range, then it is working fine. But when you are giving a very large input range, it is not working. So for any input, it should give the correct answer. For any input, it must give the correct answer. Okay. Now about efficiency. Efficiency हमने last class में थोड़ा सा discuss किया था, and efficiency we are going to evaluate on the basis of, see, there are, for any algorithm there are two things. One is time, another thing is space. Okay, so uh, these are the two things we want to optimize, right? Either, see, in you can imagine one thing, that when you increase the space drastically, then your time will be decreasing. Okay, for example, if you are storing certain things, and to store that particular thing you use a huge amount of space, then when we'll be seeing different sorting algorithms, when we'll be seeing different indexing kind of thing, then you will be able to understand this very perfectly. But now just try to imagine, or if you can imagine that, it will better कि when you increase the space drastically, अगर तुम किसी को स्टोर करने के लिए कोई चीज को बहुत ज्यादा स्पेस यूज कर रहे हो, then your time taken to retrieve the data stored in that space will be very low. Similarly, when you are decreasing the space for storing something, then your time required for retrieving the data is huge. So when time is going, space is going up, time will be reduced. When space is less, time will be more. Okay, but we have to make an balance between time and space. तो हमें क्या करना पड़ेगा, अभी कोई भी एल्गोरिथम का इन दोनों जो टाइम एंड स्पेस रिलेटेड जो भी एफिशिएंसी है उसको हम चेक करेंगे. ओके, जब इंडेक्सिंग वगैरह पढ़ेंगे, ये चीज जो मैं अप डाउन बता रहा हूँ कि व्हेन स्पेस विल इंक्रीज, टाइम विल डिक्रीज, व्हेन स्पेस विल, सी, every algorithm that we are going to analyze or people are working on, they want to just optimize it in the basis, on the basis of time or on the basis of space. Like space nowadays is not a very big problem, because you know very small chip can accumulate thousands of gigabytes of data. So space is not a big thing. But again, the amount of data every day is increasing drastically as well, so it is also a matter of concern. But time is one thing which we are very much concerned about. Okay, so these two things can be analyzed on the basis of time complexity and space complexity. Okay, टाइम कॉम्प्लेक्सिटी का मैंने डेफिनेशन थोड़ा बताया था लास्ट क्लास में. So for understanding time complexity, the amount of time taken by an algorithm to execute in terms of input size. हम input size क्यों ले रहे हैं? Because we cannot analyze simply on the basis of time, because time may vary depending on system to system. Lower end system it will take more time, and higher end system for the same algorithm it will take less time. So directly time cannot be considered as a parameter to evaluate the time complexity of an algorithm. Okay, जो algorithm लिखा है उसका तो कोई गलती नहीं है ना, तुम slow system में run करो इसलिए वो ज़्यादा time ले रहे हैं. So we have to find the amount of time taken by the algorithm in terms of input size. Okay. उसका और एक मैंने बताया था क्या कि नंबर ऑफ टाइम्स पर्टिकुलर ऑपरेशन is being repeated could be another way of understanding time complexity. Number of times a particular operation is being repeated. तो यहाँ पर we have various notations to represent the time complexity, to which we are not going to get into details. Just मैं बता दे रहा हूँ कि हमारे पास क्या होता है. एक तुम्हारा बिग ओ नोटेशन होता है, बिग ओ नोटेशन जिसको कि बिग ओ से हम ऐसे रिप्रेजेंट करते हैं. ओके, अब ठीक है. और एक होता है तुम्हारा ओमेगा नोटेशन, जिसको हम ऐसे ओमेगा से रिप्रेजेंट करते हैं. एंड देयर इज अ कॉल्ड थीटा नोटेशन, जिसको हम ऐसे थीटा से नोट उसको रिप्रेजेंट करते हैं. ओके, we do not need to understand any of these things. These things are going to be covered in the. So these notations mean different things, but यहाँ पर हम जब कोई भी टाइम कॉम्प्लेक्सिटी को एनालाइज करेंगे, we are going to simply call them order of. डिटेल में जब पढ़ोगे तो तुम बोलोगे बिगो नोटेशन ऑफ और ओमेगा ऑफ और थीटा ऑफ तुम बोलोगे, बट दिस बिगो ऑफ, ओमेगा ऑफ और थीटा ऑफ you are not going to use, because for this you need a detailed analysis. For this you need to understand the asymptotic notation, इसको बोलते हैं asymptotic notation. Asymptotic notations. There are some other notations as well, जैसे कि स्मॉल ओ नोटेशन. ओके, स्मॉल ओमेगा नोटेशन, स्मॉल ओ में कुछ इस तरह से होगा, स्मॉल ओ स्मॉल ओमेगा में कुछ इस तरह से होगा नोटेशन. सो देयर आर अदर नोटेशंस एज वेल, जो कि हम डिटेल में नहीं पढ़ेंगे. हम बस ओवरऑल हम जानेंगे, हम उसको रिप्रेजेंट करेंगे लाइक ऑर्डर ऑफ. ठीक है, मैं जब ऑर्डर ऑफ वगैरह बोल रहा हूँ तो थोड़ा इफ राइट नाउ यू आर नॉट बीइंग एबल टू अंडरस्टैंड, जस्ट लिसन केयरफुली and have patience. In the next 5-10 minutes you will be able to understand everything. Okay, so these 3 to 5 notations are there, but we will be overall calling it order of something. Okay, now the fastest the order, as I told you in the last class, I gave you one or two examples. So it starts from order of 1. Order of 1 means constant time. जब मैं बोल रहा हूँ constant time, इसका ये मतलब है कि we know how many time exactly the operation is going to be repeated. Okay, either there is no repetition while executing a line, or we know exactly how many times a particular line is going to be repeated. जैसे मैंने लास्ट क्लास में एग्जांपल दिया था कि 10 टाइम. ओके, अगर छोटा सा कोड लिखेंगे, मतलब एक लाइन ही लिख रहा हूँ मैं, आई एम नॉट राइटिंग द एंटायर कोड. एग्जांपल, let us suppose int a equal to 5, printf percentile d a. Okay, now this line will be repeated only one time because there is no loop or nothing. This line is going to be repeated only for one time. Okay, and जब तुम्हारा ओवरऑल तुम उसका पूरा एंटायर कोड का जब तुम निकाल रहे हो कि उसका ऑर्डर क्या होना चाहिए एंड व्हाट इज द टाइम कॉम्प्लेक्सिटी ऑफ दैट कोड स्निपेट, देन यू हैव टू फाइंड द ऑर्डर ऑफ ईच लाइन एग्जीक्यूटिंग. ओके, सो इन दिस केस द फर्स्ट लाइन विल बी रिपीटेड ओनली वन टाइम, सो इसका कितना हो गया ऑर्डर ऑफ वन कांस्टेंट टाइम. द सेकंड लाइन आल्सो विल बी एग्जीक्यूटेड ओनली वन टाइम, सो द ऑर्डर विल बी ऑर्डर ऑफ वन. सो इट विल बी ऑर्डर ऑफ वन plus order of 1, which is nothing but order of 1 only. Okay, यहाँ पर जब हम और कर रहे हैं या प्लस कर रहे हैं, इसका वैल्यू कैसे आ रहा है कि which is having the maximum order can dominate rest of the orders. Okay, यहाँ पर दोनों क्योंकि कांस्टेंट है, तो यहाँ पर जो भी तुम्हारा यहाँ पर order of 1, so by adding them it will be order of 1 only. Okay, now another example, int a equal to 20, int arr a for I equal to 0, I less than a, I plus plus. What I did, I first let us suppose array of I equal to I into 10, something like this. Then print f percentile d array of I. Now this line will executed for one time, right? This line will be executed for one time. For loop, inside the loop हमारा जो ये वाला लाइन है वो कितने बार एग्जीक्यूट होगा? 20 times. Now this line also will be going to be executed for 20 times. Okay, now because one time it will be order of 1, because again this is one time order of 1, and as per the definition of time complexity we know exactly 20 times this line is going to be executed. When you know exactly, then again it will be order of constant only, so order of 1. ये भी तुम्हारा order of 1 होगा, and this also will give you order of 1. So this both two lines will give time complexity of order of 1. So all together, including the for loop, what we have, order of 1 plus order of 1 plus order of 20 plus order of 20. ये दोनों अलग अलग मैंने लिख दिया, order of 20, order of 20, sorry order of 1 again. मतलब 20 टाइम execute होगा, but because constant, so order of 1 only. So all together this will be an order of constant time complexity. Okay, and when you are seeing an algorithm having order of constant time complexity, you can say it is the fastest one. For example, when let us suppose you want to search, there is an array. Okay, there is an array of some n size, and you want to search for an algorithm. And जब order of 1 में बोल रहा हूँ, उसका क्या मतलब है यहाँ पर? You are given with an array, okay, of some elements, and you are given a task to search an element in that array. Okay, now what you did, you wrote a code in such a way that the first element you are going to check, that is the element you are looking for. Normally तुम लोग ने बाइनरी जो linear search पढ़ा होगा, and binary search some people might be knowing. Linear search, like you are going to check each element one by one, and whenever there is a match found, you are going to stop there, right? Binary search में भी कुछ उस तरह से होता है, जो कि हम अगर नहीं पता है तो आगे देखेंगे. But in both the cases, if you notice, then you are going to check with multiple elements, and you don't know how many elements you are going to check so that you can find the actual element you are looking for, but you are going to check with multiple elements, and eventually you will find the element you are looking for, right? But for example, let us suppose you have written a code जो कि आज तक कभी किसी ने नहीं लिखा है अभी तक. Okay, the first element you are searching, means the first element you are checking with, that element is the one you are looking for. So in that case, your none of the operation is being repeated. जैसे कि यहाँ पर linear search में हम जो checking वाला repetition है, हम इसके साथ check कर रहे हैं पहले, नहीं ये मेरा element नहीं है. Now checking with this element, no, again this is not my element. Checking with this element, again not my element. Checking with this, not my element. So when I check with this element, now I can say that okay, I have reached the element I was looking for. So this checking process I am repeating many times. And as per the definition of time complexity, any operation if you are repeating, then that will decide the time complexity of the entire code, right? तुम ऐसा कुछ लिख रहे हो, as for which, like whichever element you check in the first occasion, that is the element you are looking for. So that will give you a time complexity of order of 1 or constant time. But as of now, hashing जब हम आगे पढ़ेंगे, somehow can give you time, somehow can give you a constant time complexity. Otherwise, we do not have any such algorithm which can give you a constant time complexity while searching an element. Very difficult. Okay, and all the research that is going on in data structure, that is based on how to reduce the time complexity of searching algorithm, basically. Because see, everything, Google, YouTube, Facebook, everything you see, they work on a search based algorithm. YouTube हो गया, Google हो गया, कुछ भी. Okay, so and they have a huge database, very huge database. Now what you are looking for, how come they are just giving you in a couple of seconds? You search something in Google, and within seconds you can retrieve, they'll show you the links, right? Then how they are like how they are able to search from the entire database of so big size and giving you the output in so less time. So because they have optimized their search algorithms. Okay, everything is based on the search algorithm, and the searching thing basically we are trying to um, approach towards order of 1 time complexity. Okay, order of constant time complexity. So people are working still. So this is about constant time complexity or order of 1 time complexity. Okay. Then next one is order of n. Okay, when the time complexity will depend directly on the input size. For example, यहाँ पर मैं क्या करूँगा, एक for loop में चला रहा हूँ, for I equal to 0, I less than equal to n, I plus plus, or I less than n. Okay, I plus plus, and here print f percentile d I. Now this particular line will be executing how many times? N times, depending on the value of n. It could be 5, it could be 5 into 10 to the power 100, could be anything. Okay, the value of n could be 5, the value of n could be 5 into 10 to the 100. So whoever is running the program had like whoever will see the program will not be able to figure out what could be the maximum value of n. Could be anything, right? And because of that, we cannot give a constant time complexity in this case. So this will have to be dependent on the input size, dependent on the size of the loop, dependent on the maximum size of the iteration variable. So order of n this will be. Okay, यहाँ पर अगर हम और कुछ ऐड कर देंगे, जैसे कि ये हो गया printf हमने कर दिया, उसके बाद और एक for loop में चला रहा हूँ, for I equal to 1, I less than 100, I plus plus, print f hello. Okay, now this particular line will run for n time, and this line will run for 100 time. And because we know 100 is a constant, and every time you run the entire code from here to here, this will run n times, means we do not know how many times, and this will run exactly for 100 times. So this will be of order of one time complexity, this particular line. So overall, it will be order of n plus order of 1, which is nothing but order of n. As I told you, the higher time complexity will always dominate the lower one. Okay, अगर हम higher lower के बारे में बात कर रहे हैं, then I must give you the order. तो सबसे जो कम है वो होता है order of 1. Okay, उससे ज़्यादा जो होगा वो होगा order of log n. Then we are going to have order of n. Then we are going to have order of n log n. सब हम देखेंगे एक एक करके. उसके बाद order of n square normally. Then order of 2 to the power n. Then order of n to the power k. Okay, so this is the order. सबसे जो कम टाइम कॉम्प्लेक्सिटी होता है वो होता है तुम्हारा ऑर्डर ऑफ 1 का. फास्टेस्ट वन, दिस इज द स्लोएस्ट वन. ठीक है, ऑर्डर ऑफ 1, ऑर्डर ऑफ log n, order of n, order of n log n, order of n square. So if somewhere you'll see one line is one line is going to be repeated for order 2 to the power n times. Okay, 2 to the power n times, and another line is going to be repeated for n square time. So for the first line, the time complexity will be order of 2 to the power n. For the second line, the time complexity will be order of n square. So in this case, what we can say, the overall time complexity of that code is order of 2 to the power n. और ये जो dominate हो रहा है, ये किस लिए dominate हो रहा है? Because for a large number, large n of value of k, value of n, okay, the higher order time complexity, the higher order can make the lower orders negligible. जैसे कि n square और 2 to the power n के केस में, when the value of n is, let us suppose 2, तो n square का वैल्यू कितना होगा 4, 2 to the power n का वैल्यू कितना होगा 4. तो n जब 2 हो रहा है तो तुम्हारा क्या हो रहा है, दोनों का वैल्यू 4 हो रहा है, तो नो डिफरेंस. लेट अस सपोज n वैल्यू इज 5 नाउ. n square will be 2 to the power 5 square 25, 2 to the power n, 2 to the power 5 32. तो यहाँ पर तुम देख सकते हो I increase the value of n and now 2 to the power n is bigger than n square. Similarly, if you have the value of n 100, then 100 square will be only 10,000, right? But 2 to the power 100 will be, I don't know how much it will be a very big number actually. Okay, 2 to the power 10 तो तुम्हारा कितना होता है, 2 to the power 10 होता है 1024. So 2 to the power 100 सोच लो कितना बड़ा होगा. So this will be some 7 to 8 digit number. So compared to this 7 to 8 digit number, this 10,000 would be negligible. We can simply ignore this particular factor, right? So इसलिए तुम्हारा जितना higher order होगा, तो higher order for a large n of value of n, तो higher order can always make the lower orders negligible. Okay, similarly anything you can compare, like if you are going to compare n log n and log n, obviously n log n for some value it will be dominant enough compared to log n, so log n can be ignored easily. Okay, similarly, is my screen visible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Similarly, if you go with n to the power more than 3 or 5, okay, that time it will be more than 2 to the power n. Okay, so this is the sequence you must remember, because in GATE, those who are interested in higher studies, in GATE, they normally ask this question. They will give and they will ask you like what is the order. They may ask directly or they may ask indirectly. They will give 4 programs, T1, T2, T3, T4, and arrange their time complexity. T1 greater than T2 greater than T3, something like that. So this sequence you must remember. Okay. So if I ask you now, what will be at which place I should put order of n square log n? If I say, यहाँ पर मैंने mention नहीं किया n square log n. So if I say, let us suppose n square log n, there is something n square log n. तो इसको हम कहाँ पर place करेंगे? बताओ।
तो 2 to the power n के पहले,
हैं
ऑर्डर ऑफ 2 to the power n के जस्ट पहले।
जस्ट पहले, हाँ, क्योंकि हम n स्क्वायर के बाद तो होगा ऑब्वियसली, क्योंकि वी आर मल्टीप्लाइंग समथिंग टू n स्क्वायर, सो इट विल बी डेफिनेटली मोर देन n स्क्वायर। सो लेकिन 2 टू द पावर n से वो बड़ा है कि नहीं, तो उसके लिए तुम क्या कर सकते हो, थोड़ा सा कुछ वैल्यूज ले सकते हो जस्ट फॉर कंपैरिजन। ओके, सो मोस्ट this will be placed here only, but they may give you some different types of time complexities. So you can start with a very small value, 1 or 2 or 5, then you can go with some 30 40 50 100 like that, so that you can figure it out कि सबसे जो तुम्हारा जो पोजीशन होगा वो कहाँ पर होगा। ओके, so we discussed about order of 1 and order of n। तो order of n basically तुम्हारा कहाँ पर होगा, wherever you see a loop like this, okay, I equal to 1 to n, and you are repeating some statement inside, तो वहां पर तुम्हारा क्या हो जाएगा, इस वाले फॉर लूप का जो टाइम कॉम्प्लेक्सिटी वो क्या हो जाएगा, ऑर्डर ऑफ n हो जाएगा। ओके, द टाइम कॉम्प्लेक्सिटी ऑफ दिस पर्टिकुलर फॉर लूप विल बी ऑर्डर ऑफ n। ओके, नाउ ऑर्डर ऑफ n स्क्वायर। तो n स्क्वायर के केस में अगेन बहुत सिंपल सा एग्जांपल है, फॉर I equal to 0, I less than n, I plus plus, and inside that, let us suppose I have another for loop। क्योंकि बहुत सारे प्रॉब्लम में तुमने देखे होगा, जैसे बबल सॉर्ट, इन केस ऑफ बबल सॉर्ट यू हैव वन नेस्टेड for loop, right? So I equal to 0, I less than n, I plus plus। So in this case also, and we have a printf inside that, let us suppose hello। Okay, now how many times this line is going to be repeated? Clearly it is visible how many times this for loop will be repeated n times, and for each value of I, so this is j,
n square.
okay, this line will be repeated for I times, you can see now।
Yes, sir.
Yes, sir.
So this line for this for loop, because this is just a for loop, so you can say that this will repeat for n times, and this also will be repeated for n times, but for each value of I, this will repeat for n times, so obviously it will be n into n, right? So the entire time complexity will be order of n square। Okay, now wherever you will find such kind of examples or two for loops are there, you can say that it will be order of n square। I'm giving you another example, you just tell me। For I equal to 1, I less than n, I plus plus, for I equal to 1, sorry, j equal to 1, j less than n by 2, j plus plus, inside that we have certain statements। What will be the time complexity? as per your
N square.
understanding? N square. Okay. So now for this line, some of you might be thinking कि ये तो 1 से start हो रहा है, n से पहले end हो रहा है. So this is nothing but n minus 1 time. It will be repeated for n minus 1 time. Fine. It will be repeated for n minus 1 time. But again, you can completely ignore this constant minus 1 because for a huge value of n, this minus 1 will not play any significant role. Okay. So if n equal to 5, then 5 minus 1, 4 is okay. But when n value is 1 million, 1 million से अगर एक हम minus कर देंगे, so there will be no problem, right? Similarly, this will be n by 2 times. Okay. So this particular line, this for loop will repeat for n by 2 times. Again, any constant that is added, subtracted, multiplied, or divided, you can simply ignore that constant. That constant might be as big as possible. Okay, कितना भी बड़ा क्यों ना हो वो constant, you can simply ignore the constant. So यहाँ पर जो constant by 2 है, इसको हम ignore कर सकते हैं. And the reason is, we can for a very large value of n, that constant can be simply negligible. जैसे कि अगर मैं बोलता हूँ कि n into 10 to the power 5 है, 1 lakh, n into 1 lakh. So this is a very big constant. So you must be thinking, no, this is a very big constant, so I cannot simply ignore it. But let us suppose n value equal to 10 to the power 200. Okay, and there you are having 10 to the power 5. So don't you think in front of 10 to the 200, this 10 to the 5 is very small? So we do not know the value of n, right? It could be very big, but we do know the value of 10 to the 5. It is 10 to the 5 only. That is why no matter how big the constant is, it can always be felt like it can always be made negligible in front of a bigger value of n. That is why no matter what the constant is, you can simply ignore it. May it be added, subtracted, multiplied, or divided. So यहाँ पर n minus 1 into n by 2. But ignoring both the constants, it will be n into n. So again, it will be order of n square. Okay. So order of n square हम निकाल सकते हैं अभी. Okay. Similarly, if I ask about order of n to the power cube, 3 for loop होने चाहिए, right? 3 for loop होने चाहिए और यहाँ पर तुम्हारा कुछ 3 loops होने चाहिए. Every time each loop will be repeated some n times, right? n मतलब 2n हो सकता है, 5n हो सकता है, n by 2 हो सकता है, n plus 5 हो सकता है, but some factor of n times it must be repeated. Okay. So order of 1, order of n, and order of n square, I think everyone is clear, and they will be able to figure out when they see a code. By looking at the code, you can figure out कि इसका time complexity क्या होना चाहिए. Okay. Now order of log n. Order of log n, ठीक है. Order of log n देखो एक सिंपल सा रूल है, बहुत ही सिंपल सा रूल है. ये हम जो order of log n कर रहे हैं, means here we are basically talking about order of log n base 2. Okay, we are talking about order of log n base 2. So one ground rule you remember, and that will help you very much. Whenever the input size is divided into half in every iteration, ये line में लिख दे रहा हूँ. Whenever the input size is divided roughly into half in each iteration, time complexity will be order of log n. मैं explain करूँगा, don't worry, will be order of log n. तो ये rule तुम आगे हम जाके देखेंगे कि there are so many algorithms where this particular thing is being happening. Input size is divided roughly into half. So there you can say that there must be a log n. Apart from that, there may be another factor, जैसे n log n होता है, or n square log n. So there could be some other factor, but n log n will definitely be there. So what it is saying, when the input size is divided roughly, you might have seen such algorithms जैसे कि तुम्हारा binary search. In case of binary search, it happens. So what do you mean by this? Input size is divided roughly into half. पहले मैं एक simple सा for example देके बताता हूँ. For loop, for I equal to 1, I less than n, I equal to I by 2. I equal to I into 2. Inside that, printf hello. Okay. Now, how many times this loop will run? How many times hello will be printed? Okay. देखो यहाँ पर मैंने क्या बोला कि input size is divided roughly into half. So you have to understand कि ये जो मैंने line यहाँ पर बोला है, this particular line is exactly similar to this line. Maybe not looking directly same, but this is similar. Okay. So let us suppose we have a value of n that is equal to 16. The value of n that is equal to 16. So what we did, we start with I equal to 1. So 1 time hello printed. Okay. Now I equal to I into 2. So I became 2. Hello. Okay. So then I into 2. It became 4. Hello. Another time it printed. Then 4 becomes 8. Again you print hello. Okay. Then 8 becomes 16. Another at the time you print hello. Okay. So how many times? 5 times. Okay. तो यहाँ पर अगर मैं सिंपल इक्वल टू यहाँ पर लेस देन है
सर ग्रेटर देन लेस देन इक्वल टू
लेस देन तो ये प्रिंट नहीं होगा तुम बोल रहे हो राइट यस दैट इज व्हाट यू आर सेइंग
यस सर
बट इट डजंट मैटर आई एम टेलिंग यू ये तुम्हारा जैसे कि मैंने बोला था ना कि +1 -1 ये सब चलता है तो यहाँ पर रफली आई कैन सी दैट कि 5 टाइम्स इफ देयर इज नो इक्वल टू देन 4 टाइम्स अगर यहाँ पर हम इक्वल टू ऐड कर देंगे देन देयर विल बी 5 टाइम्स ओके सो रिलेशन बिटवीन 16 and 4 or 5 whatever it might be, what is the relation between 16 and this 4 and 5? If it is 16 and 4 then I can say that 4 equal to log 16 base 2 right सबको पता है ये चीज
यस सर
ये अगर नहीं पता है तो वो अलग बात है तुम देख लो थोड़ा मैथ देख लो ठीक है तो 4 इक्वल टू log 16 base 2 and 5 इक्वल टू log 16 base 2 plus 1 right we cannot have any other value either log n होगा डायरेक्टली log n base 2 और log n base 2 plus 1 होगा तो यहाँ पर हम इसको अगर जनरलाइज वे में लिखेंगे देन log 2 base log n base 2 और log n base 2 plus 1 and as I already told you this plus 1 minus 1 into 5 multiplied with any constant or divided by any constant can easily be ignored so doesn't matter कि यहाँ पर तुम्हारा equal to हो या ना हो whether equal to is there or not whether it is running for 4 time or 5 time the overall time complexity will be order of log n तो यहाँ पर मैंने बोला था कि इनपुट साइज हाफ में डिवाइड हो रहा है यहाँ पर भी तुम देखो एवरी टाइम यू आर डबलिंग द वैल्यू ऑफ आई ओके इनिशियली इट वाज 1 देन यू मेड इट ट्वाइस देन मेड इट ट्वाइस एंड ट्वाइस ओके सो आइदर यू आर सी द सिंपल अप्रोच इज आइदर यू स्टार्ट फ्रॉम n and you reach to 1 or you start from 1 and you reach to n okay जैसे कि कोई भी फॉर लूप हम देख रहे हैं either the initial value of I will be n and you have to reach to 1 so that जैसे मैंने बोला था कोई भी algorithm है it has to be finite it cannot run for indefinite period of time so when you reach to 1 you have to stop the loop so starting from n you can reach to 1 or initially the value of I will be 1 and you are going to reach to n. So in either case, दोनों सेम है तुम्हारे, यहाँ पर भी n से 1 पहुंचने में जितना टाइम लगेगा 1 से n पहुंचने में भी उतना ही टाइम लगेगा. Okay, now how many steps or how many iterations you are taking to reach from either n to 1 or 1 to n, that basically will tell you the time complexity. In case of a simple for loop, when where you have I equal to 1, I less than n and I plus plus, so 1 से n पहुंचने के लिए मुझे n steps लग रहे हैं. Okay, so that is the order of n. But in case of this kind of thing where I'm writing I equal to I into 2, or I can simply write something like this: for I equal to n, I greater than equal to 1, I equal to I divided by 2. I equal to I divided by 2. Again, some statements are there. Okay, so starting from n, I am reaching to 1 by dividing the value of I to every iteration. Okay, so in this way or in this way, in both the way, starting from the initial index value till the last index value, you take log n iteration to reach. Okay, and because of that, the statements inside will be executed for log n time. Okay, and that is
Sir?
why the overall time complexity will be log n.
Sir, suppose if in inside a for loop it is I equals to 1.
Yeah. I was about to come to that. Okay, so another example: for I equal to n, I greater than equal to 1, I equal to I by 2. Inside that we have another for loop for j equal to m. Okay, j greater than equal to 1 and j minus minus. Okay, some statements are there. In this case, this will be repeated for how many times? You can say log n times, right? This will be repeated for how many times? M
M
times.
times.
Right? So overall, for each value of I, this line is going to be repeated. Thus, inner for loop is going to be repeated for m times. Okay, so it will be order of log n into order of m, and n and m both are unknown values. We do not know the value of n or m; they are not constant. So simply it will be order of m log n. यहाँ पर मैंने m और n दो अलग अलग एग्जांपल ले लिया, but sometimes it can be same. n log n हो सकता है. Okay, जहाँ पर तुम सेम एरे के ऊपर यूज कर रहे हो and the size of the array is n, so it can be n log n similarly. Okay, so यहाँ पर तुम्हारा क्या होगा टाइम कॉम्प्लेक्सिटी ऑर्डर ऑफ m log n. जो डाउट था वो क्लियर हुआ कि और कुछ पूछ रहे थे?
सर मेरा दूसरा डाउट था.
हाँ बोलो.
हाँ sir, here what we are doing is inside the for loop we are putting I equals to 1, I is less than equal to n, I is equals to I into 2. But suppose if inside our for loop it is I equals to 1, I is less than equal to n by 2, I plus plus. Here also we are dividing it into half. So the time complexity will be 2
You are
or
not
log n.
dividing n. Okay, see, you are not dividing n into half. Means you are dividing, but see, when you are writing I less than equal to n by 2, that means you have set the maximum range. ठीक है, यहाँ पर तुमने मैक्सिमम रेंज यहाँ पर सेट कर दिया. n का वैल्यू कुछ भी होगा तो वो हाफ तक ही जाएगा. इट्स नॉट दैट कि एवरी टाइम यू आर डिवाइडिंग इट टू हाफ.
Sir, so is it like we are iterating from I equals to 1 to n by 2, and in log n ka case we are iterating from 1 to n, but we are skipping 2.
Yeah, exactly.
Okay.
Stepping with a multiplication of 2, not plus 2. Okay. यहाँ पर मैंने लाइन लिखा है, input size is divided roughly into half. There are many occasions. Okay, this is one of the ways. This means यहाँ पर जो मैंने example दिया, this particular example satisfy this line. Input size divided roughly into half in each iteration. So every iteration में either we are increasing or decreasing the loop variable with 2, or when we are going to see an example with array, that time we'll see we are dividing the array into half. Okay, every single time, not that once we divided into half and again we are processing the half of the array. No, every single iteration we are dividing the array into half. Okay, so today we will end here. Next class again we will continue from order of log n only. So in the meantime, if you can go through some books, some website, you can go and let me know if you have any doubts. Okay. तो यहाँ पर जब हम डिवाइडेड रफली बाय हाफ कर रहे हैं तो इसका बहुत सारे इंस्टेंसेस हो सकते हैं, बहुत सारे एग्जांपल्स हो सकते हैं, हम एक एक करके सारा कवर करेंगे, ठीक है। लेकिन ये चीज जो है इसको तुम कंफ्यूज मत होना, यहाँ पर हम बस जो मैक्सिमम रेंज है वो हम सेट कर रहे हैं। Okay, you are not this particular thing is not satisfying the line I have mentioned above.
Yes, sir.
Okay?